Good morning, everyone. As a part of our series of lectures on stereochemistry, today I am going to teach you about the nomenclatures. I am Dr. Karthik Rao, Assistant Professor in the Department of Organic Chemistry, Gayatri Vidya Parishad College for Degree and PhD courses. The first nomenclature is plus or minus symbol. In the previous video, I have explained you about the plane polarized light. How an enantiomer will rotate a plane polarized light. So if an enantiomer rotates the plane polarized light towards right side or clockwise direction, it is called as dextrorotatory. So the dextrorotatory has symbol plus, whereas an enantiomer that rotates the plane polarized light towards the left side or anti-clockwise direction is called as levorotatory. The symbol is minus. Okay, so an enantiomer which rotates the plane polarized light either right side is called as positive or plus symbol. If it rotates in the left side, it is called as minus symbol. So this is the sign which is denoted for only for the plane polarized light. Okay, remember that this is a denotation only for the plane polarized light. Suppose it is a Miso compound. A Miso compound is a compound which has or a compound which has both plus and minus in equal halves. That means it cannot rotate the plane polarized light. So such a compound is denoted by plus or minus, okay, in the same bracket. Or racemic mixture, otherwise called as a racemic mixture which has both the enantiomers in the equal quantity, that is 50-50%. Then it is given a symbol plus or minus in a brackets. So this is the first nomenclature where we assign for enantiomers. This is only given for the enantiomers which can rotate the plane polarized light. Okay, so this is the first nomenclature. So then comes the most important one, DL nomenclature. So this is the oldest nomenclature where the scientists have not discovered the enantiomers or diastereomers, whichever. So previously they have to assign some nomenclature for the molecules. So they thought that some reference compound should be available to give a nomenclature of the molecule. That means by looking the molecule, you have to give the nomenclature of that compound. So for that purpose, they have chosen a compound called as glyceraldehyde. So as you see, you can see the structure of the glyceraldehyde here. So this is the glyceraldehyde. So simple molecule with a carbon has 4 different groups. One is CHO, CH2OH, OH and H. So this is a simple molecule where the OH, this is represented in the Fisher's projection. So where the OH is on the right side, so below the OH is on the left side. So they thought that by taking this molecule as an arbitrary or as a reference, we can assign the molecules with same configuration or with the same structure. So they thought, and they given the name for this compound as D. That means dextro, or otherwise it is a right side. The OH group is on the right side. So whenever the glyceraldehyde with the OH group, that is a functional group, is on the right side, then it is called as D. If it is on the left side, it is called as L. Okay, so the in glyceraldehyde, the OH group is on the left side of the Fisher's projection is called as L configuration, whereas if it is on the right side, it is called as D configuration. This is what they have given for glyceraldehyde. So now they thought that we do some reactions with this glyceraldehyde. Let us suppose if we oxidize this glyceraldehyde, what happens? The CHO will be converted to COOH. Then this COOH and the molecule, whole molecule is not reverting, or it is not changing any configuration. Therefore, all the molecules or all the compounds which are coming from this glyceraldehyde should be assigned as a D. That means this OH is not changing its position. That is why all the molecules which are coming from this or which are generated by this molecule are given as a D. In the same way, they done the reduction also. So this OH doesn't change its position. So they have given these structures which are coming out from this glyceraldehyde as D structures. So they named them as a D. So in the same manner, they did the same experiment with the L glyceraldehyde also. This time also there is no change with the configuration. Therefore, these two structures are also given as a name as L, that is derived from the L glyceraldehyde. Therefore, they have given the name as L. So this is the first nomenclature which is given to the compounds with the same, which are generated from the glyceraldehyde. Now they thought that give this nomenclature to the other compounds also. So they have chosen that a group or a functional group, okay, the functional group, it may be a OH, it may be a NH2 or any other functional group which is present on the highest numbered stereo center or the bottom carbon. Okay, so if you see this, this is the carbon. There are two stereo centers here. So the highest number is this one and this is the second one. Therefore, this is called as highest number stereo center, or from the bottom it is the first one. Therefore, this carbon, if the functional group, it may be a OH, it may be an NH2, it may be a SH, whatever it may be, if it is present on the left side, then the molecules are denoted as L. Okay, any molecule, for any molecule or for any sugars, it is especially useful for these sugars. So for any sugars, if the functional group attached to the highest numbered stereo center or bottom, it is the first stereo center from the bottom, then if it is present on the left side, it is given as L. If the same the functional group is present on the right side, it is given as D. So this is the nomenclature which is given to the sugar molecules. So in the same way, they have assigned the same D and L configuration to the amino acids also. So the amino acid has the functional group of NH2 on the right side is called as D. If the amino acid has the NH2 on the left side, it is called as L. So D and L amino acids are present in the nature. So in the olden times, they used to call these amino acids and sugars with the D and L configurations. So nowadays also it is very useful for calling or for giving a name for these amino acids and sugars. So widely used nomenclature for the amino acids and sugars. So this is also called as relative configuration. Remember that this is also called as relative configuration or DL configuration. Okay, so this is the first configuration, first nomenclature which was given to the compounds with the like structure of the glyceraldehyde. So they have taken the glyceraldehyde as the arbitrary compound or the compound as a reference. So they have given the name. If the function group is on the right side, it is called as D. If the function group is on the left side, it is called as L. So this is the nomenclature which they have given. So the now most important and widely accepted molecules have been coming. So before that, let us assign the relative configuration of the following. If you see this is the OH is on the right side, therefore this is called as D. Whatever the name is, name of the sugar, we call it before the name of the sugar, we put it as a D. So this is the L form and this is D form. So this is L form, but this is not a stereogenic center. Okay, If we see this, this is not the stereogenic molecule, this is a Miso compound where the OH and OH are same. Okay, so therefore this has a symmetry element. We do not consider this as a simple unit. Okay, in the same way, if we assign this also, this is a D, this is L, this is D, and this is a D. Here also the same symmetry is there. Therefore, this is a Miso compound. We do not assign the structure. Okay, so now these are the DL configuration. Now we will go to the most important nomenclature of the stereochemical molecules, that is R and S, or RS configuration, which is also called as absolute configuration. Okay, RS configuration is also called as absolute configuration. So this is applied to all the molecules which has a stereogenic center. So RS configuration is given to a molecule which has a stereogenic center. That means the stereogenic center means a carbon having 4 different groups. So this configuration was given by Chon-Ingold-Kellogg. So that is why it is also called as CIP configuration. Okay, Chon-Ingold-Kellogg configuration, or otherwise called as, it is also called as CIP configuration, which is given by Chon-Ingold-Kellogg. So this is approved by IUPAC, so which is a international standards. Okay, so internationally it is approved one. Therefore, we use this configuration widely for giving a name to the molecule which has a stereogenic center. So let us see how the molecule is given a name, that is R and S configuration, whether the molecule has R configuration or S configuration. So to name the molecule with R and S configuration, Chon, Ingold and Kellogg has given a set of rules or priority order to this one. So we will see the rules and priority order of the configurations. So now let us start the rule number 1. So the rule number 1 states that the stereogenic center or chiral center having 4 different atoms are numbered according to the priority order as 1, 2, 3 and 4. Okay, so that means the chiral center should be named or should be numbered with the priority order. So this priority order depends on the atomic number of the atom. Suppose we see this molecule. Here we have 4 different atoms: bromine, oxygen, hydrogen and carbon attached to the stereogenic center or chiral center. According to this rule, the priority number is given to the atom which has highest atomic number. So the bromine is the highest atomic number, so it is given as the 1. If you see the second molecule, here also the 4 different groups are attached and they are given the priority order. So if we give the priority order to this one, we can see that these are the numbers given to the first molecule. So bromine has the first one, OH is second, CH3 is third, and hydrogen is the fourth because of due to the atomic number order. In the same way, we can assign the numbers for the second molecule, and we can assign the numbers for the third molecule also. So these numbers are given according to the priority. This priority has come from the atomic number. So according to the atomic number, we are giving the priority. So this is the first rule. So this is the priority order which is given from the lowest to the highest. That is, hydrogen is the lowest priority and the iodine is the highest according to the atomic number. So let us see how this priority order differs. So next rule is the lowest priority order, whichever the atom it may be, doesn't matter which atom is present on the lowest one, it should be present at the below the plane of paper or below the plane or away from the viewer. that means at the dashed wedge. Okay, if you see this molecule, so this is the lowest order. If you give the number according to this one, so NH2 is the highest one, that is therefore 1 is given to the NH2. So because carbon, nitrogen is the highest atomic number, then we give the lowest atomic number, that is 4 to the hydrogen and 3 to CH3. COOH has the second one. So this is the priority order. If you see the second molecule also, we have given the same priority order according to the atomic number. The NH2 gives the first one, and C6H5 goes to second one, 3 is Ce2H5, and 4 is CH3. We will see later how this numbering is given to the all the carbohydrates. So now our rule states that the lowest priority group, that means here this is the fourth group is hydrogen, here the fourth group is CH3. So whatever the group may be, doesn't matter which one is present, but this fourth priority group should be present below the plane. Okay, that means it should be present away from the viewer. Away from the viewer means it is represented as a dotted lines. So this is the second rule. So first rule states that all the atoms or the groups attached to the stereogenic center or chiral center should be assigned according to that priority order that I have given. The second rule states that the fourth priority order group or the atom should be present away from the viewer, or it should be below the plane, that means in the dotted lines. So here you can see that these two molecules have the fourth group away from the viewer, so there is no problem with that. So the next rule, the important rule, that is the third one. Now what we do is we hold this fourth group, that is away from the viewer, we hold this one and rotate, or mentally you think that we are rotating from 1 to 2, 2 to 3. So this is 1, this is the fourth one, we are holding this fourth one and we are assigning the numbers for these molecules. So we can see that the two molecules are assigned. Now we are moving from 1 to 2, 2 to 3. So by holding the fourth priority order group, and we are moving this priority order number from 1 to 2, 2 to 3. So if we move this from 1 to 2 and 3, if it is moving in the clockwise direction, okay, if you are moving in a clockwise direction, then the molecule is assigned with the R configuration, or the molecule is labeled with R. Okay, if the same molecule, if we are moving in the opposite direction, that means in the anti-clockwise direction. So if you see this molecule, second molecule, it is moving from 1, 2, 3, and this is in the anti-clockwise direction. Therefore we assign this molecule as S. So this is what we are assigning, R and S. So R means if we are moving in a clockwise direction, then the molecule is said to be R. If you are moving in the anti-clockwise direction, the molecule is said to be S. So these three are the major rules which are useful for assigning R and S configurations for any molecule. These three are enough to assign the R and S configuration to the molecule. Okay, the first one is, first of all, you have to assign the priority order according to their atomic number. Second one is you have to place this fourth group in the away from the viewer. And third rule is, by holding this fourth group, you move from 1 to 2, 2 to 3. If it is a clockwise direction, assign it as R. If it is anti-clockwise direction, assign it as S. So this is what the rule states. So completed. So now we have some difficulties. In this example, you can see that all the three groups which are present attached to the carbon are same. That means all are carbon. So then how would we give the number of priority? All three are carbon. In nitrogen we are giving the number 1, no problem for that one because it is the highest atomic number. But the three here present here are the same carbons, same atomic number, then how would we how would we give the preference order? So if you see this one also, you can give the preference order to the COOH given as a 2 and CH3 given as 3. How can we give this COOH as a second priority? So this is the this is the problem with the priority order. So we have to assign some more rules for defining the priority order. For that, the rule 4 comes into the position. So the rule number 4 states that if the same mass, if the atom has the same isotope, for example, if the hydrogen has the isotope of deuterium, that these two are same isotopes, that means they have the same atomic number. So how can we differ this one? Now we have to consider the mass. So we have to consider the atomic mass of these two elements, and the higher atomic mass will go the priority order. So therefore, whenever there are deuterium and hydrogen, the deuterium is given the highest priority order than the hydrogen. So deuterium is given the priority. So one is NH2. So here the carbon is the second senior. Then 2 is given to the carbon, and 3 is given to the deuterium before hydrogen. Because even though they are these two are same atomic number, the mass number is highest for the deuterium. Therefore, it is given the highest priority. So you can see the second molecule also the same thing is going. So that is deuterium is given the highest priority than the hydrogen. So this is the rule number 4. So now comes the number 5, which states that whenever an atom or a group present on the chiral center has the same atom or the same first atom, that means if you see this molecule, this is the molecule, this is the chiral center, and it has 4 different groups. So this group is oxygen, this group is also oxygen, that means these two are same. Okay, these two atoms are same. Therefore, these two atoms have the same atomic number. Now, what to do? We have to go to the next atom which is attached to this one. Okay, so we have to go. We have to consider the next atom. That means here it is CH3. Here it is hydrogen. So which is most senior? Which is most highest atomic number? The carbon has the highest atomic number than the hydrogen. Therefore, we consider this as the first one, and we consider this as the second one. Okay, so whenever there are same atoms present or attached to the chiral center, then you cancel it out and go to the next atom which is attached to this molecule or the group. Okay, we go to the next atom. Here we can see that here the oxygen, and this is also oxygen. Now we are going to the next atom which is attached to the oxygen, that is CH3. Here the oxygen has the hydrogen. So the atomic order priority is CH3, and carbon is the highest atomic number than the hydrogen. Therefore, we give this priority as the 1. Okay, so this is number 1, 2, 3, and 4. In the same way, if you see this one, here this carbon, this is the chiral center, and it has 3 same carbons. So carbons are same, therefore we cancel out this one. So next we go to the next atom, that is here it is hydrogen. If I take the pen, I will show you. So this is carbon, so cancel it out. This is cancelled out, and this is also carbon. So 3 are cancelled out. So next go to the next atom here. Here it is hydrogen, cancel it out. Here it is also hydrogen, cancel it out. Here also 1 hydrogen is there. 2 more hydrogens are there. You will cancel 1 hydrogen. So then you go to the next one. These 3 also same. So priority order should be given. If they are same, then go to the next one. Here we are going to the next one. This is carbon. Again you cancel it out. And here also carbon, cancel it out. Here it is hydrogen. So it is not given the priority order. So it is least priority than these two, because here these two are carbons, whereas here it is hydrogen. Hydrogen has the least atomic number. Therefore, we cannot consider this as the priority order. Okay. So now the competition between these two only. So the next atom. So here these two are also cancelled. Then go to the next atom. Here it is oxygen. Okay, so here also there is an oxygen. You cancel it out. All are cancelled. Now again go to the next one. Here all the three atoms are again occupied. So go to the next priority. Here it is CH3, cancel out. Here it is also CH3, cancel out. Now this is the hydrogen, whereas this is OCH3. That means the carbon has the highest atomic number. Therefore we give the priority to this atom or this group as the highest priority, because we cancel all the groups which are alike with this, these two molecules. So these two groups. Therefore the remaining is here it is carbon, here it is hydrogen. These two differ. So now we assign the priority order, that is 1, this is 2, this is 3 and 4. So in the same way we can cancel this also. So carbon, carbon, carbon. Then hydrogen, hydrogen, hydrogen. Again it has a hydrogen, hydrogen, hydrogen. Then comes the CH3. Here it is carbon, you cancel this carbon and this is the carbon. But here it is no carbon, therefore it is the least priority order. So hydrogen has the least priority order. So it is given the least one. So already fourth is fixed. That is hydrogen is the fourth one. Don't worry about that one. So the next priority is 3. So this is given this group is given 3. Now coming to this. So it has 3 hydrogens. Again this has 2 hydrogens. These 2 hydrogens will be cancelled out with the 2 hydrogens here. Now only one hydrogen is present. Now this is a carbon and this is only one hydrogen. So therefore the carbon wins the race according to the atomic number. So it is given the most priority order. So 1 is this one, 2 is this, 3 is this and 4 is this. Okay. Now you give the you hold this fourth one and give the R and S configuration. Now you are turning this 1 to 2, 2 to 3. So this is the arrangement. So it is called as S. Okay. In the same way here also you give the priority order and you are assigning the R or S. So same yes. So here also the same one. So it is given as yes. Okay. So this is the rule number 5. That means whenever you see a same atoms present on the chiral center, you go to the next priority atom. Okay. So now you can see this one also. So here the chiral center is here. This is CH3. So given as a third one, no problem with the. So here you can see that CH2 are same. So you cancel these two. So next comes the OH and OCH. This is therefore the same thing. So 1, 2, 3, 4. So this is 1, then this is 2, this is 3, and this is 4. Okay. So the same way you can assign all the groups as 1, 2, 3, 4, and give the S or R and S configurations. So this is the rule number 5. So coming to the rule number 6. Suppose the chiral center has the secondary, tertiary and primary carbons. You give the priority for the tertiary, then secondary, then primary. So which the rule number 5 also states the same thing. So we are just moving to the next 1, 2, 3 and 4. Okay. So this 6th rule says that whenever there is a tertiary, secondary and primary carbons attached to the chiral center, give the priority order with the tertiary, then secondary, then primary. So rule number 7. If the chiral center has a group with a double bond or triple bonds, okay, suppose a chiral center has a double bonds and triple bonds, then consider that molecule or consider that group is linked with the second one as a duplicate. Duplicate means, suppose if you see the first molecule, here this is a CH4. That means C is having a double bonded with oxygen. That means this carbon has 2 oxygens. Okay, so this we can write it as a is attached to one oxygen and another oxygen, and another one is hydrogen. Okay, so double bond is equivalent to the duplicate. That means it is attached to 2 oxygens. So triple bond means that means it is attached to the 3. So according to this, you have to give the priority order. Suppose this is the chiral center, and this is carbon. This is carbon. This we can give as a 3. So no doubt about this. This is CH and this is CH. So there is only one hydrogen. Next is oxygen. Here also oxygen is present, but here the carbon is attached to the second oxygen. That means this is the second oxygen, means it is a double bond. Therefore we are calling this as a second oxygen. So that is why it is given the priority order 1, 2 and 3. Now we can see this. Now it is a double bonded and this is triple bond. If both are present, so this is oxygen, directly we can give it as a 1, no problem. So suppose this is the next condition where double bond and triple bonds are present. So this is considered as a 2 equivalence, that is 2 carbon. This carbon is attached with the 2 carbons. Now this carbon is attached with the 3 carbons. So therefore the priority order is given to this one. So 1, 2, 3, and assign the R and S configuration. So the next rule. So next is the most important rule, where if you see this molecule and we assign the priority orders, this is 1, this is 2, this is 3 and this is 4. So where is the fourth priority group? It is on the plane. You can see this hydrogen is on the plane. It is not behind the plane, or it is not away from the viewer. So now we are violating the rule number 2, where it states that the fourth group should be away from the viewer, but here it is violating. So how to assign such a molecules? So for this we have to interchange. Okay, we have to interchange any 2 groups. So we have to interchange the groups, that is any 2 groups twice. Remember that they have to interchange twice and then assign the R and S configuration. Now let us see this molecule. So now first interchange is, I am interchanging this hydrogen with the oxygen OH which is present on the backside, because this hydrogen, this fourth group, should be coming to the backside. Therefore I am first interchanging this fourth group to the backside and I am bringing this OH to the plane. So this is my first interchange. Then you don't touch this hydrogen, that means you don't touch the fourth group. The remaining 3 groups you have to interchange any 2. I can interchange with OH and OCH3, or OCH3 and OCH3, any it may be, OH and CH3, whatever you like, and that is your wish. So I am now changing the OH and the CH3. I am now changing these 2 positions. Now assign the priority order 1, 2, 3 and 4. Now the fourth group has come to the back side, and you can give the assign the R and S configuration. Now it is revolving from here to here, therefore it is called as R. Okay, so this is the direction of the clockwise direction, therefore it is given as R. So like this you have to interchange any 2 groups if the hydrogen is present on the away from if the fourth group, not the hydrogen, any fourth group. Okay, so if any fourth group is present on the plane or away from the or on the above the plane, on the plane or above the plane, that is it is not present on the below the plane, then you have to interchange any 2 groups such that the fourth priority atom or fourth priority group should come to the back side. Okay, that is the main criteria. That means you are bringing the fourth priority group onto the back side. So you have to interchange twice. Remember that it has to be interchanged twice. First interchange, we are bringing the fourth priority order to the back side, and the second your wish. So it is given as, so rule number 9. So in the previous example we have seen that the fourth priority group is on the plane. So we are just rotating it or we are just replacing it with the backside priority. So there is no problem. But if the group is on the is represented like this, that means if it is represented in a Fisher's projection, then you have to assume that this vertical line and these are the vertical and horizontal lines. So therefore this vertical line is indicated as a dotted, that means they are present back side. So these two groups are present on the back side, and these two groups are on the front side. That means these are wedge shape. Okay, so the horizontal line indicates that they are on the front, and the vertical line indicates that they are on the back side. So therefore you have to again interchange, as I said previously, that the hydrogen should be on the back side. That means it should come on the vertical line. It should be the fourth priority group should be present on the vertical line. So in order to bring this in the vertical line, you have to again interchange twice. So this is the priority order. Then you can see that fourth priority order is on the horizontal line. So therefore we have to bring this fourth priority order onto the vertical line. So in order to do that, the first interchange, I am bringing the fourth priority order first on the vertical line. It may be exchanged with the COOH or CH3, whatever it may be, that is your wish. The second interchange, you should not touch the hydrogen which is present on the vertical line, and the remaining can be interchanged. So this is the interchange. Now assign the priority orders again and give the direction. Now you can see that it is in the anti-clockwise direction, therefore it is called as yes. So this is the rule number 9. So here we end the rules to give the RS configuration. So all the rules states that only 3 are the main rules. That is, first one is you should give the priority order. Second one is the fourth priority order should be on the back side, and the third one is if it is rotating on the clockwise direction, give R. If it is rotating on the anti-clockwise direction, give S. Those are the 3 main rules. The remaining rules are the additional rules which states that if the how to assign the priority order if there are different scenarios, and if the fourth priority group is on the plane or above the plane, then how to interchange. So by collective all these rules, we can assign different molecules. So let us see the stereogenic centers with two or more stereogenic centers. Let us say that this is the stereogenic, this is the molecule which has 2 stereogenic centers. So let us assign the numbers for this one. I have assigned all the numbers for this one. So now, and the first thing is you have to, this is the first stereogenic center. So we are assigning the R and S for this one. You can see this fourth priority group is on the horizontal. So first interchange, that is hydrogen is coming on this one. You can see that this is the priority line. So we have a method called as, so let us say that this is the stereogenic center. We assign the stereogenic like this, so in a plus symbol. Now, so we write these priority orders like this one. This is fourth one, this is second, this is 1, and this is 2. Okay. Now interchange this one. You can directly interchange with the molecules. Otherwise, this is the easy method where 1, 2, 3, 4 priority orders are given to the stereogenic center like this, and you interchange with the other one. So again I am writing the same stereogenic center. Now I am moving this fourth group to this vertical position. Therefore 4 will be coming here and 2 will be coming here. Okay, sorry, this is 3, right? This is 3. This is 3. So 3 will be remaining in the same position and 1 will be remaining in the same position. Now second interchange should be made. So in order to do that, I am changing 2 and 3. So you can see this one, and I am changing this 1 and 2. Okay, so therefore I am writing this one. So here comes 1, here comes 2, here comes 4, and here comes the 3. So either you can assign the numbers by interchanging directly the groups present on the molecule, so like this in the down direction. Otherwise you can assign easily by giving the priority order number to this configuration. This is the plus symbol is for the features configuration, and you can assign the numbers to it. Now interchange, first interchange and the second interchange. Now give the whether it is a R or S. So it is a anti-clockwise direction, so it is S. Okay, so this is how it is rotating. sorry, this is R, because this is written like this. Sorry. So you are giving the RNS configuration like this. Delete it. Okay. So now the configuration is given. Sorry for that. So 1, it is moving 2 and 3. Okay, this is the direction. Therefore, this is the direction 1, 2, 3, and we can assign the configuration as R. So this is given as. In the same way, we can do the for the second stereogenic center also. Again, you interchange the stereogenic center as a molecule like this, and you can assign the order of priority, or otherwise you can draw this as a second stereogenic center also like this, and you should give the priority orders 4, 2, 1, and 3. Now interchange with this one, again the plus symbol for the Fisher's projection. So 4 should come here, so 3 will be coming here, 2 will be coming here, and 1 is here. The second interchange again. So I am changing with these two. That means 3 here, and 1 here, 4 here, and 2 here. So you can assign the priority order now. This is the priority order, so it is given as a yes. So the next one is more than one stereo center. How many isomers are present for a more than one chiral centers? So that is 2 to the power of n stereoisomers will be present. Therefore, if we take this molecule, there are 2 stereogenic centers. Therefore, 2 to the power of 2, that is 4. And if we take these 3 stereogenic centers are present, therefore, stereogenic centers or chiral centers, whatever it may be. So 2 to the power of 3, that is 8. And if we take the glucose-like structures, we can assign it as 16. So therefore, there are 16 isomers for this molecule, which has 4 stereo centers or 4 chiral centers. Because 16 isomers means 8 will be the different isomers and 8 will be the mirror images of the molecule. Here also we can see that this is one molecule, and we can write the another molecule. So 2 are different molecules, and other 2 are the mirror images of these 2 molecules. In the same way, 4 are the different molecules, and we can take the mirror image of the molecule with this one. So like that, we can assign or we can draw number of stereogenic centers, and you have to write each and every stereogenic center with the R and S configuration. Suppose this is the stereogenic center, you have to assign this as a R and S, this should be assigned R and S. Like that, you have to assign all the stereogenic centers. Okay, so this is the assignment for you. So write different possible stereoisomers for the following and give the R and S configuration. Okay, so thank you for listening. Thank you.